Okay, so welcome back. So let's see what we've got in store. This is question number 6. And now things get a little bit tricky here because it's also drawing on your prior knowledge, right? The question 6 reads, in the diagram, AB is the line y equals a half x plus 2. So this is AB, right? That's the line that we've got over there. Let me just get a pen. So that's our line. Let's add some color because things are more fun when there's color. Okay, AB is the line y equals a half x plus 2, so that's AB. Y is equal to a half x plus 2, that's my AB line, which passes through the point B, which is this point over here, which has coordinates 7 and B. In other words, B is unknown. Okay, determine the value of B and hence find the size of angle ABC. Is angle A, B, and C, right? Correct to one decimal point. So let's see how we can do that. So before I continue, I actually want to remind you about some things about straight lines, right? And if you remember, we've got a general formula for a straight line, which says the following, which says that y is equal to mx plus c. Now when you think about this, the y is equal to mx plus c is the general formula of a straight line, where m is the gradient, and c happens to be the y-intercept, right? Now the y-intercept is where something cuts the y-axis. So if I take a line, and let's think of a line that looks like this. There's that. There's my axes, right? And I'm going to draw a line. So for argument's sake, let's say that this line cuts here at 3. Oops. There we go. And it cuts here at -2. So 3 and -2, those are my intercepts. This is the x-intercept, that's the y-intercept. And if I have to list the intercepts, I can say, well, my y-intercept for this particular line is going to be 0 on the x-axis, right? Because we don't move left and right for this particular point. So 0 on the x-axis and 3 on the y. And then I can say, okay, well, what is the y-intercept? That's the y-intercept. What's the x-intercept? Where does it cut the x-axis? So I'll put that over here. The x-intercept, right? X-intercept, that's going to be 0 on the y because there's no movement up or down for this particular point, and it's going to be -2 on the x, right? Let's just make that a better 2, -2 on the x. Now if you had to find the gradient, you can simply use the y-intercept over the x-intercept, and let's do that over here. Let's say m is going to be the y-intercept over the x-intercept. In other words, I'm saying 0 minus 3, or 3 minus 0. Let's make it 3 minus 0. Right? Exactly the same way we found the gradients in the past, over 0 minus -2. 0 minus -2. Now if you remember, we've done the way to find the equation of a straight line previously, and we could say, well, okay, it's y is equal to mx plus c. Let's just do that over here. Y is equal to mx plus c. We can substitute in a point and we can find the value of c. Well, there's another way to do it. If you know the y-intercept and you know the gradient, then you can simply say that the equation of that line is y is equal to m. In this case, m is going to be 3 over 2 x, and c in this case is 3, and you can just say plus 3, and then you've got the equation of the line. There we go. Right, that's my equation of this line. Okay, so getting back to what we previously found, right, let's use some of that knowledge, and if you're unsure, I suggest you let me just bring it up again quickly. If you're unsure of what's happening over here, this being y equals mx plus c, m the gradient, c the y-intercept, and how I found this equation just by knowing the gradient and already having the y-intercept, then if you're unsure, just take a moment, pause the video, read through it again, and then come back. Okay, so we will continue in the meantime. Okay, so we know that this equation is y is equal to mx plus c. In this case, m is a half. So there's a few things we know about the line AB. One of that is that the gradient of the line AB, I'm going to put the MAB, is equal to a half. Right. Where did I get that from? I just read it straight off the equation. That's the half in front of the x. That's the m. And the y-intercept, there's coordinates here. This thing has got coordinates. The coordinates of this thing is going to be 0 on the x and positive 2 on the y. And again, I got that positive 2 from reading it off the equation, like so. Okay, so now the question is, determine the value of b. Well, I've got 2 points with one little unknown there, and I know the value of the gradient. So I can construct an equation that says MAB is equal to, I'm going to call this xb and yb, and let's just call this point, let's call this point D, right? I'm going to stick the b's and minus the d. Okay, so I'm going to say that's going to be b minus 2 divided by 7 minus 0. Okay, and I also know this value here, so I can fill that in, right? That's going to be a half is equal to b minus 2 divided by 7. Okay, and with a little bit of calculations we can find the value of b here. That's going to be 7 multiplied by a half. That's going to be half of 7, which is 3.5. 3.5 is equal to b minus 2, which then means that 3.5 plus 2 is equal to b, right? And so there we've got the first thing. We've got the coordinates of b is equal, position b here, it's 7 and 5.5. Oh, that's a little bit of a fail. Okay, there we go. Okay, so there we've got b. So let's move on to the next part, right? We've got b. I'm going to list that there as 5.5. Right. Okay, and hence find the size of angle ABC. Now angle ABC is actually this angle over here. Right, that's angle ABC. Okay, how are we going to do that? So there's a little trick. We already know things up our sleeve. We can say we know that tan theta or tan theta is equal to the gradient, right? So I can easily find this angle, and I can easily find this angle over here. So let's try and do that. I'm going to try and find that angle over there. Okay, so I know that this gradient is a half, and let's put that in. Tan theta is equal to a half. Okay. And so with a little bit of help with the calculator, I've got theta is equal to tan of second function of the inverse of tan of a half. And I can find out that that will give me 26 rounded to one decimal point, 26.6. 26.6 degrees. Right, so now I know that this thing over here is 26.6 degrees. What about this thing on this side? Let's actually just put that up on the screen here. So b is 5.5. We've just calculated this as 26.6, as you can see we've done over there. Tan theta is equal to the gradient of this line, and then we took the inverse of tan to find that that angle is 26.6. So now what we can do is we can say, well, okay, let's find this angle, and you can see more or less where I'm going with this. Okay, let's find that angle. In order to find this angle, again, we need some help. We need to actually find the gradient of that line and then use tan theta again. So how am I going to do that? Well, we're just going to take a blue line, little blue mark over there, and we're going to say, well, if that's 5.5, the gradient of that is going to be, let's write it over here, MBC. Oops. MBC. Oops. Okay. MBC is going to be the y's minus the x's, so 5.5 minus minus 5 So let's make it 5.5 minus 5 divided by 7 minus 11. Right. What does that give us? That's going to give us 10.5 divided by minus 4. So let's put that in calculator. 10.5 divided by minus 4. It's going to give us, oops, and that should give us negative 21 over 8. Right, minus 21 over 8. So I want to, again, I want to get to finding that angle. So how do I find the angle? Well, I say that's the gradient. I say tan theta of the gradient is equal to negative 21 over 8. Okay, and now I can just say theta is equal to 180 degrees minus tan of 21 over 8. Okay, so of course I've just made that the positive version. So okay, so we go second function tan of 21 over 8, and after I subtract, this should give me 69.1. That will give me the little angle over there. If I take tan of 21 over 8, I get 69.1. Right, but I'm not interested in that. I'm interested in this outside angle. And in fact, once you've got this angle, now you can use the laws of a triangle, or you can say 110.9, 110 degrees, 0.9. Oops. 110.9 degrees. Okay, so this angle on this side is going to be 110.9 degrees. Now, why did I use this angle and not the other side? Well, one of the rules that you know is actually this one. Exterior angle of a triangle. You see, we're building up all the revision here. The exterior angle of a triangle is equal to the sum of the interior opposite angles. So if this was little angle A and this was B and this was C, then there's a relationship that's true amongst A, B, and C. It's that angle A, right, plus B is equal to C. So if you know that this here, for example, is 30 degrees and this ends up to be, well, let's say 10 degrees, then this angle must be 20 degrees. And that's exactly what I'm doing here. I'm saying, let me call the previous angle on this side, let me call it theta. We know the value of theta. I know this exterior angle, so what will that be? So you can set up an equation. You can say 26. We can then say 26, 6 degrees, right, plus, call this angle, let's call it angle ABC. I'm just going to call it angle B for now, right, is equal to 110.9 degrees. Right, so therefore angle B will give us 110.9 degrees minus 26.6, which should give you 84.3 degrees. And there we go, that's our solution. Right, it's a little bit of a tricky question. Not tricky, but I mean, if you have to learn all these concepts from scratch, here we've got two uses of the angle of inclination, and also we've seen an example where the angle of inclination in the calculator will give you the smallest of the two angles, and so to find the other one we had to say 180 minus 69.1 to give us 110.9, and then similarly we had to use the gradients to determine the value of B by reading it off the equation. So a little bit of revision and important things there for you to consider. Okay, well done. That's question number 6.